let's do one thing. Let's substitute whole denominator as u. Let's see what comes. After that, we can adjust. Let's see, u equals to twice x square plus 2x plus 1. Then differentiation of this du equals to what? Is to 2 to the 4 x plus differentiation of twice x is what? 2 into dx. Now if I take 2 common here, then twice x plus 1 dx. Now these two, this du, these two I can send down. Therefore du by 2 equals to twice x plus 1 into dx. Now twice x plus 1 dx become what? Du by 2. Okay. Therefore this integral is become what? Du upon 2, I am taking outside, 1 upon, this is what? This is u. This whole term is u. Okay. Therefore integration of this is half, that is log of mod of u plus some constant integration, that is half log of u is what? 2x square plus 2x plus 1 plus c. This is your answer for question number 10. Integral log of x square plus 1. This is very simple. Now this type of integration, what we used to do, we used to solve with the help of integration by parts. Integration by part is what we have. Formula is u v dx is what? U integral v dx minus integral and differentiation of first function d by dx of u integral v dx again differentiate integrate this. Now yeah, this is what? First function, this is what? Second function. Okay, now how to choose first function and second function is we have I-let rule in this preference from. Okay, I stands for inverse trigonometric, L stands for logarithmic, A stands for algebraic, T stands for trigonometric, E stands for exponential. Inverse means, like for example, inverse trigonometric function sin inverse x, cos inverse x, etc. Logarithmic function is like this form, logarithmic function. Algebraic function is x square plus twice x, etc. Trigonometric is what? Sin x, cos x. Exponential is e raised to x, a raised to x, etc. Okay. Now over here we have logarithmic function. Okay. Now this is same as I can write 1 into this. 1 into this I can write. Okay. 1 into this I can write. Okay. Now therefore 1 is what? Algebraic. Okay. Now let's consider this is first function and this is what? Second function. Okay. Therefore this is equals to what? This is equals to log of x square plus 1 integral of 1 dx minus integral of d by dx of, I'll write down for first step, d by dx of log of x square plus 1 into integral 1 dx. This again we have to integrate with respect to x. I am writing each and every step. This is what? This is formula. Okay, this is formula. Now this equals to log of x square plus 1 integration of 1 dx is what? X. So I will write here x into this minus integral differentiation of log of this. Log is what? 1 upon here 1 upon x square plus 1. Again we have to differentiate this with respect to x. Differentiation of x square plus 1 is what? Twice x plus 0. Therefore we have twice x. Now integration of 1 dx is what? We have x. Again here dx. Now x and x is what? X square. I can write here x square, and these two I can bring outside here 2. Okay. Therefore look at here. Okay. Now we have x square plus 1 in denominator. In numerator we have x square. So can I do one thing? Can I do x square plus 1 minus 1? Okay, now therefore this upon this upon this, let's write down. This equals to x into log of x square plus 1 minus 2. Minus 2 is outside. Integral this upon this. Okay, here x square plus 1 upon x square plus 1 dx minus is outside. I am keeping as it is. This minus is this minus. Okay, here integral 1 upon x square plus 1 dx, okay, is equals to x into log of x square plus 1 minus 2. Now this, okay, this gets cancelled, this and this gets cancelled. Now we have integral of 1 dx is what? X, okay, integral of 1 dx is x minus. Now we have this integral of we have integral of 1 upon a square plus x square dx is 1 by a tan inverse x by a plus 0. By applying this formula, 1 by a, here 1 by a is 1 by 1 is 1, tan inverse x by a means x upon 1, okay. Therefore, this we did substitution, no, we didn't do any substitution over here. Here all are x, therefore log of x square plus 1 minus, I am sending minus 2 inside, minus 2x minus plus 2 is there, 2 tan inverse x plus constant of integration, okay, minus plus over here 2 tan inverse x, this, okay. Now you can see in these integrations you have sine raised to 4x, cos raised to 4x over here, and here you have cos x plus sin x into cos x minus sin x. It is all from here a minus b into a plus b. So in a minus b into a plus b is what we have, a square minus b square. So if I have cos square minus sin square, what is that? That is cos of 2 theta, okay. Means the angle become twice, okay, twice x. Now here all are x over here. Now we need to adjust over here the angles, okay. So before applying this, so you should know some trigonometric formulas. Cos of 2x is equals to cos square x minus sin square x. It's going to use over here, okay. Similarly, sine of 2x here twice is equals to 2 sine of x into cos of x. Now this will use effectively over here, okay, is equals to integral sine 4x into cos 4x is said. I can say since a4 into b4 is equals to ab raised to 4, I can combine these two. Sine of x into cos of x raised to 4 into a minus b, a plus b is what we have here, a minus b into a plus b is a square minus b square. Therefore, what will come here, cos square x minus sin square x, and this dx will be over here. Now look at this trigonometric formula. Now cos square x minus sin square x is what? Cos twice x. So instead of this, I can write cos of twice x dx. Now what about here? Now we have sin x to x, okay. Here is we have sin x into cos x, but in order to have sin 2x we need twice, okay. So we need twice sine of x into cos of x, but this need to be adjusted. Can I write like this? It's inside the 4, okay, inside the power 4. What I'm doing is I'm multiplying and cancelling with 2. Why I'm doing? Because I need to apply sin 2x is what? 2 sin x into cos x. In order to apply this one, I need 2 over here. This 2 is requirement. I am cancelling with this 2. Okay. Therefore, the whole this become what? Whole this become half. It's inside the 4. Okay. Is sine of twice x raised to 4 into cos of twice x into dx. Now look at here. The angles are same. Now angles is what? Sine angle is twice x, cos angle is twice x. Okay. Now you can substitute the highest one is over here 4. Okay. Now let's try to substitute this term as u, and let's see what comes. Okay. Now let's u equals to, let's take all constants, everything. Let's see, because if you differentiate, the angles is there. Whenever you do differentiation, there will be 2 extra. So in order to get safe, so let's take whole. Okay, u equals to half sine of 2x. Then du is what? Half is constant. Differentiation of sine is what? Cos of 2x into dy dx of 2x is what? 2. Okay. Therefore, these 2 gets cancelled. Is dx. Here I have cos of 2x into dx is my du. Okay. Now this is what? This become my du. Therefore, integral, this is my u raised to 4 du. U raised to 4 into du. Okay. Now integrating this is u raised to 4 plus 1 is 5 upon 5 plus some constant. What is u? What is u? U is this. Okay. U is 1 by 2 sine of 2x raised to 5 upon 5 plus some constant. Now the integration is square root of x, after that square root of x, after that square root of x up to infinity is dx. Okay. Now there are 2-3 ways to solve this. So let's solve first with the shortest way. Now this is infinity. Okay. Now this is up to infinity. Now if we remove from infinity, if we remove one term, it doesn't affect anything. Okay. Now let's consider, let y equals to this, whole this. Okay. Let y equals to whole this, square root of x upon square root of x into square root of x, square root of x, and so on. Okay. Now is equals to, now if I remove from here to here, okay, this is same as what? This is same as, if let y is this is same as x into, since this is same as y. Okay, it is what? Y. This part from here to here up to infinity, if I consider this as a y, then therefore this term from here to here is a y. Okay, therefore it is y over here. Like squaring on both sides, squaring on both sides, we have y square equals to xy, because squaring and square root gets cancelled. Now if I cancel this, okay, if I cancel y, then y equals to x, means what? This y become x. Therefore this integral, okay, this integral, this whole integral become what? X. Okay, dx. Therefore integration of x is what? X square upon 2 plus c. Okay, this is the answer. Now another way is, let's see. Now another way to solve this is, we can separate this. Okay, now let's separate this one. This is same as integral of square root of x. Now if I take this, then what will give square root of x square root of x, because this is over here. Okay, this is over here. If then this, if I keep over here, okay, square root of x, then this, for this term, okay, for this square root will be up, since square root is there, one square root, therefore this square root will be over here. Okay. Similarly, again another will be what? Square root of x and so on. Okay. As you know, square root of x is what? X raised to half. Okay. Now this is same as x raised to half into here what? X raised to half. Here x raised to half. Again here. Okay. Now this is therefore x raised to, this is what? X raised to half. Again if I put here, then it will be what? Half. Okay. This is same as 1 by 2 into 2 is, so you can say 1 by 4. Okay. So you can write over here 1 by 4. Over here x raised to 2, here 2 into 2, here 2 square, 2 cube will come over here. Okay. 2, 1, 2, 3. Here 2, 2. 2 2 is a 4. 2 1s are 2. 2 2 is a 4. 2 3s are, here x 1 by 8 will come and so on. Okay. Since square root is there. Okay. Here into 1 by 2 you can say x raised to 1 by 2 square is same as x raised to 1 by 4. Okay. This is here, this is x raised to this. Okay. Here half. If base are equal, you can add the indices. It's half plus 1 by 4 plus 1 by 8 and so on. Okay. Into here we have dx over here, we have dx over here. Okay. Now this is same as integral x, this is summation of 1 by 2 raised to n. Okay. Where n goes from here, n goes from, if n is 0 then 1 by 1. Okay. We cannot start from 0. If n is 1, you will get 2 raised to 1 is 2. Okay. So n from 1 to what? Infinity. Okay. Into dx. Now this is geometric progression. Okay. Now this is what? It is geometric progression. Okay. With what is this? Common ratio is what? 1 by 2. Okay. With common ratio is equals to 1 by 2. Therefore the sum to here, sum to infinity terms, sum of infinity term is given by, now here integral x, here first sum is what? Here half, here now the common ratio is half is what? Is less than 1. Okay. Now you have to subtract from what? 1. Okay. If the common ratio is greater than 1, then that common ratio should be subtracted, that minus 1. Okay. Since common ratio is half is less than 1, this is the formula. Okay. Here into dx. Therefore what is this? X raised to half. Here half. Okay. If you take LCM over here, you will get 2 minus 1. Half minus 1 is 1 minus 1 is half. Okay. So half, if I bring up 2 by 1, 2 gets cancelled. Here I have only x, integral x dx. Integral x dx is what? X square upon 2 plus c. Okay. This is the answer for 6 for the year 2020 MIT Integration Bee Qualifying exam. Now this is very simple one. So let's do one thing. This is quadratic over here. Let's expand this and see what will come. Okay. Now this is same as, let's expand integral 1 upon x square plus a minus b the whole square is a square minus twice ab plus b square into dx. This is same as what? X plus x is what? Twice x. Here twice x square minus 2x plus 1 dx. Now let's consider this part. Let's consider twice x square minus 2x minus plus 1. Now let's take 2 common. If you are not taking 2 common also, that's fine. But for convenience, let's make quadratic equations, the coefficient of quadratic equations as 1. Okay. Now, otherwise, let's do one thing. Let's write one step over here is equals to. Let's write one step over here is equals to. I am taking 2 common integral 1 upon. If I take 2 common, it will be what? X square minus 2 I already taken x plus half, because half and half 2. This what I am taking 2, right? 2 common. So then this 2x square twice x, these two gets cancelled, you are getting 1. Okay, therefore let's remove this and let's write, instead of 1, let's write half. Okay, let's remove this. What I'm doing is I'm taking what? This is dx. I'm taking 2 common. I'm making the coefficient of x square, quadratic equation, the coefficient x square become 1. Okay. Therefore, let's consider this one, this section. Let's consider x square minus x plus half is equals to, let's make a minus b the whole square, since minus is there, is equals to a square minus twice ab plus b square. Now here we have x square minus 2. For formula I need 2. Since it's already x, I need to write x over here. But I need to get only minus x. I already have minus 2x. In order to get minus x, I need to put half. 2 gets cancelled, x. A square minus twice ab plus b square is I need, plus half minus 1 by 2 the whole square. Why? This is extra. I'm cancelling with this. This half is over here. Okay. But from here to here is x minus 1 by 2 the whole square, and plus half over here minus 1 by 2 the whole square is 4. And this is same as x minus half the whole square plus, if you take LCM over here, you'll get 4, 2 minus 1 here. Okay, here 2 ones are 2. Therefore, x minus 1 by 2 the whole square plus here 1 by 4. 1 by 4 is same as 1 by 2 the whole square. Now, instead of this, I can write like this, by half outside 1 upon x minus half the whole square plus 1 by 2 the whole square into dx. Remember what we have? We have one formula, integral of, we have formula over here. I will write over here. Integral of 1 upon x square plus a square dx is 1 by a tan inverse x upon a plus c. Okay. By applying this formula, here x is what? X minus 2. Constant term is what? Half. Therefore, this is same as half 1 by a. Half is we already have. Okay. 1 upon a means what? Here half. Okay. 1 upon 1 by a tan inverse x by a. Here x is x minus half upon a is half plus some constant. Now these two and these two gets cancelled. These two and these two gets cancelled. So what we have is tan inverse. If I take LCM over here, I will get twice x minus 1. Twice x minus 1 upon 2 upon half. This half and these two and these two gets cancelled. Therefore, we have tan inverse twice x minus 1 plus c. This is the required. So, is there any something which we already substitute? No. All are in terms of x. This is the required answer. Okay. Now the given integral is log of 2x upon x into log x. Now here we have log property. Log of m into n is same as log of m plus log of n. Okay. Now let's apply over here. Let's bracket this. Okay. Let's see what happens before integration. Let's simplify it. This is same as log of 2 plus log of x upon x into log x dx. Okay, be careful. Now integration is with respect to x, whatever, therefore log 2 is constant. Now let's divide. Okay, this upon this, this upon this. This is same as log of 2 upon x into log x integral dx plus integral log of x upon x into log x dx. Now log x gets cancelled. Log 2 we can bring outside since it is constant. Therefore this is same as integral, this is equals to log of 2 integral 1 upon x into log x dx plus over here. Now here integral of 1 by dx, integral of 1 by x dx. Now in this part, okay, this part is what? This part become what? This is log of x. Integral of 1 by x is what? Log of x plus c. We have not substituted anything. These are all x, okay? Log of x plus c. But for this part, okay, log 2, for this part, let's substitute. For this part, let's substitute u equals to log x. Log x, therefore du equals to 1 by x dx. So therefore this 1 by x dx become a du. Therefore this integral, I am solving this differently, and then I will substitute over here. Okay, therefore integral of 1 by x log x dx become, by substituting this, 1 dx upon x become what? Du, and this become 1 by u. Therefore integration of this is 1 by u is log of u plus c. Okay, here what is this is same as log of, what is u? U is what? Log of log x plus c. Therefore this is log of x plus this c1 and this c2. C1 and c2 are all same as, all constant. Okay, this plus c. Okay, this is required answer for this. Now in this integral you can see this is function raised to function. Here x raised to 2x. Okay, here you have function raised to function into 2 log x plus 2. Over here you have some function over here. Okay, now if you substitute, okay, this part, okay, if you can consider this part, okay, now if we substitute u equals to x raised to 2x. Now see, this can be written as, see, log n is nt. Okay, it means e raised, this can be written as e raised to log of x raised to 2x, because log and e gets cancelled. Okay, therefore this is same as, I can bring this over here. I can, by log property, I can bring over here, that is e into twice x into log of x. Okay, this is what? This is x raised to 2x can be written as this. Okay, now this is u, this is my u. Now let's differentiate. Okay, let's differentiate. Therefore du is equals to differentiating with respect to x, or you can say du upon dx is equals to over here e raised to x. You consider something like e raised to x. Okay, here e raised to x is e raised to x, whatever you have. Okay, e raised to x is e raised to 2x into log x. Again over here you have to differentiate with respect to x by applying u into v rule. Okay, now let's consider twice x as u. Twice x, d by dx of log x is what? 1 by x plus, for formula, and then log of x, d by dx of twice x is what? 2. This is same as, see, this is same as this. Okay, here if you can do reverse also, therefore this is same as, this whole term is same as x raised to 2x. Now x can cancel, you have 2 plus 2 into log 2. This is what? Du by dx. Therefore du equals to x raised to 2x into 2 plus 2 log 2 into dx. Now look, this is same as here. Hold this term. Okay, now hold this term is du. Okay, therefore this integral is integral du. Okay, now integration differentiation gets cancelled. What we have? U plus some constant. U is what? U is x raised to twice x plus some constant. Okay, this is the required answer. Now this integral of sec 4x into 10x upon sec 4x plus 4. Now here we have to use some trigonometric identities. Okay, what we have is now if I substitute, okay, if I substitute u equals to sec x, if I substitute u equals to sec x, then I will be getting what? Du equals to what? Sec x into 10x dx. Now I am getting something sec x into 10x. Yes, this is right. This will be easy one. So let's do one thing. This. Okay. Therefore, instead of is equals to, now sec x 10x into dx. Now instead of sec 4, I can break as it is. Instead of sec 4, I can write sec cube x into sec x into 10x into dx. Why? Because if I substitute u equals to sec x, I am getting whole this. Okay, instead of 4, I can say is 1 plus 3 plus 1 is 4. Okay, but these become my du upon sec of 4x plus 4. Okay, therefore this is equals to integral sec cube. Okay, what is this? Sec cube means what? U cube into whole this become du upon sec 4 is what? U raised to 4 plus what? 4. Okay, now look at in denominator. Here top is here u cube, here you have u4. Okay, now check. Okay, what is dy dx of dy du of u4 plus 4? Okay, is what? 4u cube plus 0. Okay, so u cube is there, so we need to adjust what? 4. So let's do one thing. This is same as, I need 4 1 by 4. I need 4 u cube du. Why I am writing 4? Because in order to differentiation of denominator is what? 4e cube. Okay, plus 0. So in order to get differentiation of denominator perfectly, I am adjusting 4. Okay, because these 4 and 4 gets cancelled. Okay, is what? U raised to 4 plus 4. Now if you are getting differentiation of this here, then that is log. Okay, therefore this is 1 by 4 log of denominator. Okay, log of u raised to 4 plus 4 plus c. Okay, what is 1 by 4 log of what is u? U is what? Sec x. Okay, therefore it will be what? Sec of 4x plus 4 plus c. Okay, this is the required answer. Now this integral x into 1 minus x raised to 2020. Let's try with help substitutions. Let u equals to this part, okay, here 1 minus x, then my du equals to minus, this is 0, and then minus 1 into dx is minus dx. Therefore dx equals minus du equals to dx. Instead of du I can write, instead of dx I can write minus du. And what is x? From here, what is x? X equals to what? X equals to 1 minus u. X equals to, if I bring in that side, become 1 minus u. Therefore, this integral become, what is x? X is 1 minus u. And what is 1 minus x? 1 minus x is what? U. U raised to 2020. And what is dx? Dx is what? This. Dx is minus du. Okay. Now this minus I can send outside, minus, or otherwise you can send inside. Okay, this term. If I send this minus inside, then this become here plus minus plus here u plus 1. If I am sending this minus inside, then minus 1 here, minus plus u become u minus 1 into u raised to 2020 du. What I am doing is this minus 1 I am sending to the particular term, or you can send this minus on outside, okay, according to your convenience. Now this minus I am sending this here, minus 1 minus plus. Okay, now let's separate this. Okay, here this is same as this into this is integral u raised to 1 into u raised to 2020 minus u raised to 2020, and this is integral with respect to u. Now if bases are same, we can add indices, because x raised to m into x raised to n is same as x raised to m plus n. This we have formula. Okay, therefore is integral of x raised to 1 plus 2020 is 20 u raised to 2021 minus u raised to 2020 du. Now let's integrate this. Integration of x raised to n dx is x raised to n plus 1 upon n plus 1. Okay, therefore u raised to 2021 plus 1 is what? 2022 upon 2022 minus over here u raised to 2020 is there, so add 1, 2021 upon 2021 plus some constant. What is u? U is what? 1 minus x. Here 1 minus x raised to 2022 upon 2022 minus 1 minus x raised to 2021 upon 2021 plus c. This is the answer.